Okay. All right. Welcome, everyone, to the yellow brick road of spatial data infrastructures, boundaries, roads, and address points. Oh, my. Yes, I love it. This is a presentation by one of the friends at this point, folks who I've known for a couple of years now, from a company called One Spatial. And I'm going to tell you a little bit about Sheila and Melissa. But before I do that, I'd like to remind you that you do have chat features available to you. So if at any point in time during the presentation something piques your interest, you want to ask more, or you want to make a comment, please feel free to do so in the chat. You're not able to unmute or turn on your video, but we would love to hear from you in the chat. Also, any of the reactions are also available. So if you want to clap or you want to send some laugh at something, you can do that too. Okay. So we'll go ahead and get started. I'd like to introduce Sheila and Melissa. Sheila Stephenson is the CEO for One Spatial Inc. of the Americas. She has over 30 years of experience in the geospatial industry, 23 of which were with Esri. During her years there, she moved from the initial role of technical sales into management, taking on the role of regional manager of the South Central U.S. Esri office. Following 11 years in that role, she moved to Washington, D.C. area and took over management of the Federal Sciences sales team. During her tenure, also supported numerous international efforts, including support to Esri's Latin American distributors and support of various open geospatial events around the globe. Sheila brings great excitement to the support of developing out implementations of One Spatial capabilities across the Americas, recognizing the intrinsic value One Integrate brings to the enterprise of data systems, both spatial and non-geospatial. She finds great satisfaction in enabling data managers with capabilities to more efficiently and effectively ensure that their data is fit for purpose. Welcome, Sheila.
Thank you.
We also are joined by Melissa Ubaldo. Melissa is a solutions engineer for One Spatial Inc. She has hands-on experience with various federal and state and local government projects focused on building smarter solutions for pervasive data and workflow management challenges. Her involvement in multiple data conflation and integration projects has defined her experience in supporting data supply chains and proper data governance practices, currently highlighted by advising and developing the One Spatial Next Generation 911 solutions. To support this, she is also a member of NENA, the National Emergency Number Association working groups. Her greater than 9 years of experience as a GIS professional includes improving organizational data management, processes, and data supply chains. Now that we've welcomed Sheila and Melissa, I'll tell you a little bit about what they're going to share with us today on the yellow brick road of spatial data. Building spatial data's infrastructure is not an easy task. From the required collaboration to the workflow and everywhere in between, there are evil monkeys, poppies, and wicked witches along the way. Organizations must work with local data suppliers, other organizational departments, and even federal partners to support the data supply chain. If you are lucky, you can get the data suppliers to agree on a set of data governance standards to help ensure decent quality and data in a format that can be readily integrated. However, this is more often the exception rather than the rule. And often the most daunting piece of the puzzle is getting all this incoming data to align as well as to keep it aligned as updates are supplied year by year. With pressure to do more with less, support staff to manage these efforts can be hindered by lack of resources to establish as well as maintain the implementation. In this presentation, One Spatial will share the success in thwarting many of the wicked witches challenges throughout the automation and support of all aspects of spatial data infrastructure workflow. This includes our spatial data infrastructure implementation for the state of Michigan, as well as implementing data supply chains for Next Generation 911 for Georgia, Minnesota, Arizona, and LA County. They will show how these organizations are helping their partners to easily understand data requirements and are empowering them to correct issues by identifying where there are potential non-conformance in the data while providing valuable metrics on the overall health of the data over time. Lastly, once data meets an agreed upon threshold, the data is integrated with multiple sources into seamless organization-wide enterprise databases. Put on your ruby red slippers and join us to learn about how to implement and enforce data quality to support data governance within your organization. I'm really excited for this presentation. Sheila, Melissa, go ahead and take it away.
Great. Thank you very much, Megan. And thanks to all of you for joining us today. And Megan, perfect introduction on what we want to talk about. You know, Wizard of Oz was a favorite of mine as a child, and still is actually. And I really think that story aligns very closely to the whole idea of implementing a spatial data infrastructure. It can be quite challenging, but Oz at the end of it is very well worth it. So you want to move to the next slide, Melissa?
Sure.
All right. There you go. I'll let Melissa kick it off.
I'll take it. Thank you everyone again for joining us. So I would like to start off our presentation by stating the obvious, that data is everywhere. And how can it not be when our smartphones are almost as powerful as our laptops? So I did learn an interesting statistic from earlier this year. This is an article on how much data was created every day in 2020 from techjury.net. And for every second of last year, maybe you wouldn't be surprised to know that every person created 1.7 megs of data for every second. So I'm willing to bet, though, that a good chunk of that is neither interesting nor useful. But everyone in GIS community is well aware of how many organizations and individuals are eager to share their data with you. But the question is, how can you determine the level of trust that you're willing to give it? Would it be enough to actually base critical decisions off of, especially when we're talking about emergency services? And of course, that inherent distrust is not uncommon. So how do we harness value from our data? So the best starting point, I think, would be to assess what the data looks like when it's shared with us. Is the format and data type what we're used to working with? Is our schema actually laid out in such a way that we're sure that if I have a field name that says number underscore ID, you're actually referring to a unique identifier as opposed to maybe a house address number? Does the projection reflect the same precision that we want? And if we have dual carriageways, are they represented as simplified road center lines instead? So for all of these concerns, how can we assess how good or bad the data quality is? So I think what we're really asking is, what do we have to do to make this data useful to us? Are we having to convert these data formats? Are we having to remap our schemas each and every single time? Do we have to tweak precision? Do we have to make exceptions for data represented differently? And do we have to constantly build out our QC processes just to make sure that when we measure the overall quality of that data, it's actually accurate? So the main reason why we must concern ourselves with this checklist here is because, again, the abundance of data grows from the availability of multiple sources. So even if we have a methodology in place to tackle each and every single one of these bullets, an even bigger question would be that of data governance. Who maintains ownership? So I will give the floor back to Sheila for a second to go ahead and discuss how we can bring sense and harmony for this dilemma of data abundance and data governance.
Great. So really, to successfully build the spatial data infrastructure, you've got to have good collaboration. And that collaboration exists internally within your organization, as well as often externally with other entities that are going to be providing you updates and information. So there's a number of steps that need to be taken to ensure that this collaborative effort is going to be successful. You know, obviously, first, what's going to be your approach, and are there policies already in place? And if not, and if there are they certain to make sure you're going to get what you want at the end of the day? And if they're not, then what should they be? Then we also have to look at what's the process of gathering the data in, and how is that process going to fit with the workflow that you're envisioning. And then also you really need to understand and work with the people who are the subject matter experts on the data to understand not only the data itself, but also what are their needs getting back out of the spatial data infrastructure. And then obviously, how are you going to connect to these data sources? What is the workflow actually going to be to actually establish this? You know, and will it require some kind of a middleware or some kind of an interface to help this process move along and occur efficiently and effectively? So, and one of the things too that's really important at the end of the day, when you're building something as large as a spatial data infrastructure, you need to make sure that you can provide an easy to use interface so that then the people who want to use the data, the people who know that these things aren't inexpensive and you're spending a good amount of money on them, need to be able to see the results and be able to realize the benefits from those results. So Melissa, can you go to the next slide? Okay, so there's some key principles. Again, right off the top, collaboration. It's very near and dear to my heart, and I've seen that the really successful data governance and spatial data infrastructures are really based on good, solid collaboration, people coming together. And then the other thing too is that really to make a spatial data infrastructure work, it can't be a manual process. It really is important that you have the automation of the process and automating as much as possible in the process, because what you want to do is eliminate a chance for any kind of error as you're pulling all this data together. And then also, how are you going to transform the data? Like we mentioned before, data comes in all shapes and formats and different schemas. And how are we going to make sure that we can get that all into alignment and into this base that will then serve back out all of that information to everybody? And again, the validation of the data governance that needs to be established in building a spatial data infrastructure is very important, because there's a lot of moving parts in building the spatial data infrastructure, and the data is coming from a number of different sources. So you need a good, solid process for ensuring that the data is going to meet the business requirements at the end of the day. And then also being able to visualize that data and make that data very useful and available to decision makers and the people who really need access to the spatial data infrastructure. Melissa, next slide. So I'm just going to give you a tiny little bit of information about who we are, because people may not be as familiar with One Spatial. While we've been in business over in the UK for probably almost 60 years now. It's been there, established out of the Cambridge labs and at Cambridge University, England, many years ago, and we have expanded considerably into other areas of the world. And One Spatial Inc., which is my organization, is the U.S. company or the U.S. arm of the One Spatial group. And I joined One Spatial about 6 years ago. And the reason I did was because I saw the intrinsic value that the tools provided to ensure that the data is going to meet the business needs, and that the answers that were going to be derived from using that data through all the wonderful analytical tools that GIS and other systems have to offer, the answers were going to be right because it's based on fact and based on good, solid, clean data. And when I joined, I'll be honest, we had about 2 clients over here in the U.S., the U.S. Census being one, who we have implemented for the MAP Tiger data process, which the MAP is basically the master address file for the entire country, and Tiger is the road center line base, and it gets updated by some 3,200 different data providers, and we have automated that process. As a matter of fact, U.S. Census says now that it's automated to about 90%, and previously it was quite a bit of a manual process. But since that time, we've grown considerably and have implemented our tools in many different use cases and in many different areas. You'll see a lot of state and local governments, also federal governments like the USGS, and we continue to work with Census, and also into federal highways. We have a number of DOTs that are utilizing us, Caltrans and Massachusetts DOT, my home state now. And then we also have, and a lot of them are doing things like either with 911 or implementations for spatial data infrastructures like Michigan, data supply chains, and again, all the transportation use cases. And then I like to point out our work with Google as well, because Google is a different case for us, because it's not really working as much with spatial data, but working with computer-aided drafting data for their facilities, along with their asset management system. So it brings to the point that we work not only with spatial data, but also non-spatial data, because we're data agnostic. And I believe I'm going to pass it back over to you, Melissa.
Yes, thank you very much. That was a really great overview. And you covered some of the stuff that I will be covering, but I will I will expound on them. So thank you for that, Sheila. So one of the things that I think are in common with all of our different customers is we've definitely learned how critical a spatial data infrastructure is for tackling data management. So I have here a diagram of the workflow types that we typically involve in building out an SDI. So there are 5 main steps here to create a loop between the data contributors and the main database repository, or whoever is the data custodian that will be collecting all of this the data. So we begin by running an initial validation process on the data that we receive from our data contributors. When that data meets the passing quality threshold of data validation, step 2 is to actually deem that data worthy of being submitted. Because what we want to do here is, of course, make sure that every piece of data that gets submitted by contributors don't end up polluting what's already existing or what we assume to be clean in the main repository. So step 3 would then to find the deltas between the current data set and the previous submission, or the current submission versus the data that's, again, already existing in the main database. And then in step 4, we want to have those change proposal results reviewed. We'll talk about more of that later on. And then finally, when those changes are integrated into the main database, at step 5, we close the automated data supply chain by validating the data once more. So we have really structured this SDI to have data validation run all throughout. So again, we want to make sure that along the way, even as we are processing and making sure that we are not polluting the environment of our main database, we've structured data validation to be running throughout that whole process. So let's actually look at applications of this data management portal. So as Sheila mentioned, about 5 years ago, we implemented a road centerline SDI for census, which we were eventually able to replicate with Arizona DOT. But specifically for census, who accepts road data from 3,200 state, local, and tribal partners, we run data validation on their partner roads as well as their MAF Tiger roads. MAF Tiger, I think she already mentioned this earlier, stands for Master Address File, and Tiger stands for Topologically Integrated Geographic Encoding and Referencing. So a process of change detection is also used to identify equivalency between them. After a balance of automated and manual review of these change proposals, they are then applied according to level of severity and degree of confidence. And what I want to stress here is that they are completely in control of how these proposals are being applied or reviewed. You are able to configure how to control the movement of the data is in your data. So this implementation in particular has led to 90% automation of the data supply chain for census. So if we can do this for road center lines, why not tackle other layers as well? So at a statewide scale, we brought in the same SDI foundation for Michigan Geographic Framework, or MGF. We took the solution that we built for census and enhanced it further by processing not just roads, but also address points, tax parcels, PSAP boundaries, culverts, and watershed boundaries, just to name a few. These 30 plus layers are being maintained through that same loop of data validation, submission, and change detection. So we realized, how much of this is truly repeatable. So naturally, we began looking at serving the needs of the next generation 911 initiative. So what I'd like to emphasize here is that when we apply this for NG911, this SDI setup really thrives on community collaboration. So at any capacity, states, counties, cities, and local jurisdictions can contribute, and be it from the tax assessor office or the fire department, the effort to share data is encouraged. And this is true for NG911 customers, including Cal OES, Los Angeles County or LA County, the states of New Jersey, Georgia, Arizona, Michigan, and Minnesota. We are looking at the same 5 steps again with what we call the ANGI 911 rule pack that's establishing the baseline data quality standard for the initial data validation that you're seeing here. So let's run through how a data contributor can submit their data through One Data Gateway and utilize these results to address any issues that have been identified. We will start with data validation, which is what we always like to start with. A very good example of a data set that every organization maintains autonomously, but when consolidated, are actually inconsistent to say the least, is that of boundaries, highly contested layer there. So we are going to run through data validation for boundary management. And then we'll also look at how we can check data quality against other features when we submit address points and road centerline updates, again, just as an example. So with that, I'm going to move over to Data Gateway. Oh, here we go. All right, so this is One Data Gateway, and let's say for the sake of this example that I've been authorized to submit data to the state of California on behalf of Solano County. So I'm just going to go ahead and log in as a data contributor. And if I go to my assignments, I can see which data workflows I have been set up to run my data against. So because the entire configuration of these workflows are built within the One Integrate rules engine, all I have to do here within the One Data Gateway portal is pick one of these workflows and submit my data. So I'm going to go ahead and select one for our county boundaries. So let's start a new submission. See if I can find my, here we go. I'm going to submit Solano County's county boundary. Hit continue. And what's happening behind the scenes here as a pre-step is the engine is trying to configure the schema mapping. So where our submitted data in its attribute table are being matched as best as possible to what the rules have been written to run against. So it says here that all the target classes and attributes are mapped correctly. But let's go ahead and take a look at the review mapping just in case what if it didn't. So right now I'm submitting Solano County boundary, which is in my data store or in my zip file. And I'm submitting that as a target class called county boundary submission. So for the checks that have been set up in this workflow, all it requires from me is for me to have a name for my county and have a geometry, of course. So if for some reason, when we start building out these workflows, I could be required to submit more than one of these attributes and be able to map them across to what's being required of me. So what's nice about this is that I can do so. I can do so right here, and I can pick and choose how my source class will be mapped across to the target class, and only do this once because I can go to manage schema mappings and actually save that for next time. So that's kind of like just a one-time thing that I can do for my data set. And then once everything looks good, I'm going to go ahead and hit continue. So notice here, but it's still submitting that I actually have 2 instances where I'm reading in data. So first I'm reading in what I submitted, which is the county boundary for Solano County, and it's reading in the current county data set. So the way that this has been set up is it's been automatically wired up essentially to tap into the repository where all the other current county boundaries are located. All of these features are cached, so for this step here, for example, where I'm updating the geometry of submitted county, I'm not actually making changes just yet. The next step that we did here was actually just process all the adjacent counties to my Solano County because those are the only counties that I really need to check. So we run some essential geometry checks in here, and we call these essential geometry checks because these are the most common geometric errors that we find in GIS data. So because these are rules, what we are looking for is conformance of a data to the rule. So this is what we want. We want a green 100% data conformance for each and every single one of these rules. So our data set is clean of duplicate features, duplicate vertices, kickbacks, spikes, etc. The next step here is the build topology process, which breaks down our features into phases. So imagine a Venn diagram where you'll have an area where the two circles overlay each other at one point. So that shared middle area is what we want to flag as an overlap because it's a face that's being shared by at least two features. The inverse of that is, of course, the absence of a feature within a face, which will be identified as a gap. So what we want to do there is be able to identify these gaps and overlaps and flag each and every single one of those faces and identify them. And then when we run our rules here to check that the county boundary that I submitted creates no gaps or creates no overlaps, obviously, as long as there's one instance or one occurrence of each nonconformance type, my boundary is going to fail. So this is already helpful information for me, right? Knowing that if I submit my boundary as is, it'll cause all of these spatial issues. But what if I want a better visualization of these gaps and overlaps? Well, I can actually, from here, open up a cache map viewer and take a look at that myself. So our markups here are obviously along the edges because, again, we are looking for gaps and overlaps. And if we zoom in here real quick, I can, quickly do a sanity check to say, oh man, indeed, I do have these slivers of, gaps and overlaps with my adjacent county boundaries. So to empower me further, knowing that all of these data errors exist or spatial anomalies exist, this workflow has also been set up in such a way that I can export out those markups, those markup points that we saw. And the way that this has also been set up is that I can get a copy of my adjacent boundaries, because obviously that's what will give me context to these gaps and overlaps. I want to see how big and small they are, and I want to see what kind of fixes I have to make with these 659 markup points, which I can navigate to that flag our gaps and overlaps. So if I hit continue here, let's just give it a second. It will show you where I can download my output. So I can download a copy of my county boundary submissions output. And for the metrics, it's nice that we also have this PDF, this automated PDF report right here that we can take a look at. And it's basically what we just ran. So it says at this time, at this date, here's the boundary I submitted. Here's how well it went, or here's how well it performed under those rule checks. If I had any gaps and overlaps that were detected, and at the end of this all, how many issues did I end up having to fix? So again, bringing in that record of um, um, data validation statistics. All right, so I'm going to go ahead and move us over to my GIS application of choice, just as a viewer, so I can get a visualization of that exported data set. So right now we're seeing that obviously Solano County is right there in the middle. So when I bring up my markup points, which I was just exported out also, you're seeing that they're basically, you're already building the outline of the entire county. That's how many markups there are. But let's go take a look at again how these look like. So we already saw this earlier. These are kind of expected somewhat. So these tiny slivers that we're seeing, small instances of gaps and overlaps, and just to kind of look at that here, our markup is indicating that, yes, there's a gap found right here. And just to take a look at how small this actually is, we're running at 11 meters. But I think one of the more important things to highlight here as well is when we find instances like this. So we are seeing this huge overlap, and I'm calling it a bubble, between Contra Costa and Solano County. So something this wide, and let me just measure it real quick. Something as wide as this, in conflicting data between these two boundaries, these are the types of things that you want to flag and say, I need to have a conversation with Contra Costa. Like, we have to have a conversation about how we can deal with this conflicting information and land on where we want to meet, so that we can submit a more accurate boundary line, and most importantly, a boundary line that we both agree to. And just another example here, we're seeing where, probably there were different sources used by both sides about which features or which data sets to use as a basis for their county boundary lines. So we're seeing all these types of gaps as well. So let's say that, just for the sake of this example, what if for Solano County, for me as a contributor, I'm saying, okay, let me go ahead and fix it. Because if they're saying that this boundary is what should be followed, let me go ahead and fill out those gaps and move back some of those and clip out some of those overlaps. So if I fix that, I can actually go ahead and resubmit my data again within one data gateway. So in here, I can resubmit as many times as I want. I can see the history of my submissions. I can revisit some previous submissions as well. One of the other things that I have access to is the information that's been provided by the people who created this workflow. So for this example, it is the state of California. So information that can go in here are things that can help me as a data contributor to understand what is being expected of me when I run this workflow. So number one here, just as an example note, please ensure your data is in the same projection as our current county boundary. Communicate that with me so I know that I don't have any errors just due to differences in projection when I make a submission. I can also read up on what are these different validation rules that are in here, and how can I maybe ensure that I don't fail any of these rules. And also maybe we can provide a copy of the current county boundaries that are sitting in that main database repository. So it's nice to have this page right here for the data contributors to share with the data um, uh, custodians for the main repository. But what's also nice here, and we've already seen this, a version of this on the metrics, is we also have a dashboard. So it tells me the top violated rules that when I submit my data. These are obviously, I have my gaps and my overlaps as my top two violated rules. It also tells me how many submissions did I make every day or per day, and if at every submission am I actually improving over time. You're seeing a flat line here because I've just been submitting the same county boundary over and over again. And just as another example here, one of the things that you can also do with this, you can also find in this dashboard, is if we have more than one contributors running the same workflow. And I'm just going to go ahead and show an example for LA County. It's nice for us to be able to see trends in our data. So let me navigate to an example here where I have more submitters. So in here, I have one for an LA County project. As a group, as a team contributor, what is the most top violated rule? And if a lot of these people or a lot of these submitters are failing the same rule, this can give me an idea of what I probably need to have a conversation with them about, and just to understand what are these expectations that are being put on the data that they're submitting. And again, how many submissions are being made per user by day, and just comparing those conformances again over time. All right, so let's see here. We can also make another submission, because right now we just ran at validation for the county boundaries. But let's say that as again a Solano County contributor, let's say that I worked on my address points. But again, before I submit, I like to run data validation first. So let's go ahead and select our address point validation. and start that new submission. Let me go ahead and drop in a data set for address points. And again, mapping that across and trying to see how my data will be read through. Let me just go ahead and hit continue, because what I really want to show here is um, this workflow in particular has been set up to say if you're submitting your address points, um, apart from running quality checks on the address points themselves, how about we take a look at a scenario where if you submit it, are the spatial relationships between other layers in the data repository being respected or maintained? So in this example, reading in my address point submission is reading my other layers from my data repository. I mean, you can take a look at some of here. I have building footprints, I have emergency service boundaries, road center lines, etc. So we're seeing here again essential geometry checks. And the other things that we want to check is am I sure that I don't have any duplicate address points? And in here, the way that we define a duplicate address point is one that has the exact same geometry located on the exact same point with the exact same address information. And just spatial relationship checking again between address points. And in here, we're saying that an address point is expected to be inside a building. And if it is, there has to be only one address point within a building. So again, I'd like to clarify that these rules aren't set in stone. They've been written as examples, because obviously I know that some organizations and some uh, different organizations actually collect their data differently. Um, you can, of course, have multi-part or multiple points within the same building if that's supposed to be representing different units and all that good stuff. So just as kind of like an aside there, again, these rules are not set in stone. They are completely configurable to how your data is actually collected. So another example here, address points versus boundaries, just making sure that all of my address points are within a PSAP and they're within at least they're within exactly one emergency service boundary. And again, what I want to take a look at here is for all of those nonconformances found, I want to be able to find them, navigate to them, and find out and see how I can fix them. So hit continue, and that will just bring us back to the page where I can make that data download. So let's go ahead and look at how these look like. All right,
Melissa,
so just
a
very
heads
quick
up.
examples. Yes.
Yeah, just a heads up, we have about 7 minutes left.
Oh, wow, I've been talking a lot. All right. So very quickly, I'm sorry, I didn't notice. Oh my gosh. Okay, so just really quick, kind of like how these rules, how these markups can look like. So these ones, obviously, they've been marked up because we're seeing right here that they are not contained within a building. And for these ones, we're seeing that it failed the expectation that there should only be one address point within a building. Let's take a look at another one. Oh, for PSAPs, this is very important. Oh, all right. So let me bring up my PSAP real quick, because what I want to show here is if I submit my address point as is, it will cause, if somebody calls from this location right here, neither PSAP will be able to find them, just because they're currently existing in that gap. So it's nice to have these quote unquote sanity checks between my data set versus the data set that's already that's already existing in the database. It's nice to be able to see data conflicts and, really have that conversation up front and say, hey, I think this data needs to be looked at. This is how I think we should fix it. So it's really empowering for me to, be able to visualize, not just know that I have nonconformances, but how do these nonconformances look like? All right. So let's say I do also have examples for roads, but I think we can skip that. I do also want to point out or show a change detection example very quick. So in the change detection process, we're just trying to find out things that are matching, things that should be added or deleted. If they are matching, make sure that the geometry is actually matching up. And of course, the address information is also matching up. So in this example, we want to update our gray address points to match our pink address points. But clearly you're seeing here that there's some kind of tolerance that we need to take into consideration, because they all look present, except that they're just data's been shifted a little bit. So what we can do is write rules to say what we want to declare as matching and what we want to identify as something that needs to be changed or updated. So if we take a look at example here as proposals, so let's bring them up, is we're trying to find matches for each and every single one of these roads. And if I zoom in here really quick, and I do have examples right here, we're seeing where each and every single one of these, again, found a match. And just to make that, just to check these ones, so we were able to match, even though we have, instances of mixed case text and all of that. We were still able to find a match for 141 Veterans Place, Unit 311, even if those are written differently or the address information is not 100% matching. And we're seeing here where we have identified points that we don't find matches for, or the information don't match up. So what we do is we identify them as either an add or delete. So far as if it wasn't there before, we want to add it in. If it's not there anymore, we want to delete it. There are different types of things that there are different types of exceptions that you can make for rules that look at changes. And just to highlight one of them, we're seeing here where we can have multiple matches, multiple possible matches, but because of maybe restraining or having more priority to distance, and say we're saying here that this can match to that and that can match to this, but we're saying that because these 2 points are actually closer together, then we're going to say that we're putting more weight on the distance and saying that these are probably the best matches and these are probably the best matches. So we're seeing the green as the best proposal for that specific address point. All right, we are short on time because I've been talking a lot. So what let me go ahead and flash forward. All right. So we've seen through this workflow that from start to end, and I want to bring this diagram up one last time. We definitely have a wide selection of data providers, but the point here is that inherently we don't trust the data at face value, or we shouldn't. And while it might be effective to go ahead and engineer a process that go over our checklist here in the beginning before feeding that data into your repository, those processes can end up consuming too much time, it unnecessarily duplicating efforts and maybe even burning through all of your resources too quickly. So a more streamlined approach would be to build one that encourages collaborative effort to facilitate, as Dorothy, your data providers with a to facilitate a portal for your data providers with a purpose beyond making that data work for you. So why not guide them along a yellow lit brick road that educates everyone as a community on maintaining consistent high data quality standards and best practices. And finally, I don't have a good metaphor for the wizard, but definitely in this metaphor, Emerald City would be the SDI destination that we all want to venture to together. And so that's it. Sheila did mention earlier about spatial data infrastructures, and we do have a little book of spatial data infrastructure. Please visit us at onespatial.com. We have a lot of nice ebooks in there with very good information.
Well, and you can also reach out to us. You can see our emails there. And there was one very good question that was posted. And
oh, sure, yes.
Yeah, so it's from Jim Sparks, and I'll take this one, Melissa,
okay.
Where he's really talking about process and also good workflows for establishing data governance, and then as data is corrected, making sure that it gets back out to all the people and is useful. And that's really one of the whole purposes of spatial data infrastructure. And Melissa focused a lot on identifying the issues. And oftentimes when we're dealing, especially on the 911 side, the processes that the states want to employ, or the body that is providing this portal, or data validation portal for their emergency services groups, what they want to do is basically give them back where the errors are so they can make the decisions about fixing them. On the other hand, in some data cases, like those boundary cases where they're very close, there can be an authoritative source that the rules engine can automatically clean that data up. And then again, the whole process of the spatial data infrastructure is to provide that in sort of a data warehouse where everybody can get access to the cleaner, more enhanced data. And so it really does come down to, like you said, it's not really a technology issue because that's the technology is definitely there. It's coming to those agreements and standards. We have a really interesting pilot project going on in California around the boundaries themselves. As you saw, there's a lot of issues with the county boundaries within the state of California. And so what we're able to do is utilize the system where it can drive the people to the location of gaps and overlaps and the two bordering counties, and it can pinpoint a suggestion of where that should go to actually align them. And the two county boundaries who are shared, they can then agree to it or not agree to it. And simply by saying, you know, clicking or adding an attribute of yes or no, you know, that they both agreed to it or not, then the system can jump in, automatically fix those things, and then the other ones can go for further investigation. And it may be that something like they happen to know it should be at the center of it should be along the street boundary. It should be along a particular river center line. And so then those other layers can also be brought in to realign the data to them. So it's you're right, it is just in that spatial data infrastructure process, you need to make sure that the processes and the workflows are all there so that the data comes in, there's a method for how it's going to get cleaned up, and then there's a method to share it back out to all those who have provided the data and others, so that then everyone can benefit. So I hope that answers your question, Jim. And Megan, I'm sorry, I know we're 2 minutes over.
Well, thankfully we have a little bit of time built in for a break for folks. So Sheila, Melissa, thank you so much for your time today. I always learn something new whenever I hear what One Spatial is doing. Thankfully, this recording will be available. So if anybody wants to catch up on what Melissa was talking about and hear it again, you'll have access to that. So thank you so much again. And the next session starts at 11:15, the last session of the day. Thank you, everyone.
Thank you.
Thank you.